Station, this is Houston. Are you ready for the event?
Houston Station, we are ready for the event.
Vintage High School, this is Mission Control Houston. Please call station for a voice check.
Station, this is Principal Mike Pearson here with students from Vintage High School. How do you hear me?
Hey, Principal Pearson, I hear you loud and clear from the International Space Station.
Awesome, Kate. Good morning, and the rest of the crew of the International Space Station participating in Expedition 49. Welcome to the home of the Crushers. Let's give it up for Kate, everybody. Guess what, Kate? We're in the little theater right now. I bet you remember that. The Vintage student, staff, special guests, and I are extremely blessed to have this opportunity to speak with you today. Not only are we honored to talk with an astronaut currently on the International Space Station, but we are also very grateful to share this time with an alumnus of Vintage High School. You're an amazing role model for Vintage students, and we are very privileged to share this time with you. I want to introduce Jen Castellazzo now, who is the Science Department Chair at Vintage High School.
Good morning, Kate, and welcome. Our Vintage High School students are eager to ask their questions and listen to and reflect upon your answers. So without further ado, I'd like to present our first student.
Hi, Kate. My name is Kaylee Ernst, and I was wondering, what is it like to look at Earth from your perspective from space?
Hey, Kaylee, that is a great question, and that's actually one of the things that's been the most surprising and amazing to me about spaceflight. You see a lot of photographs or even videos or movies about space, but it was so surprising to me what the Earth actually looks like. It really looks like a planet. It's almost glowing. It's so bright. When we take photography, we really have to adjust our settings, and it's beautiful. And the day passes. We love to watch the continents go over. The horizon is kind of shining and glimmering, and during the night passes, you can actually see entire continents worth of thunderstorms up here.
Thank you.
Hello, my name is Diego Leyva, and I'm a sophomore here in Vintage High School. And my question is, on your journeys to becoming a space researcher, did you have any troubles or doubts? And if so, what kept you positive?
I think that's a great question because we always have some troubles and some doubts, and it's been a long career getting to the International Space Station. And so, of course, there were times along the way where I thought, you know, I can't do this as a researcher, or I can't do this as an astronaut. But if you kind of keep your head down and just keep plugging away, it's actually pretty amazing where you end up. You guys may even find yourself on the space station one day.
Thank you.
Hi, Kate. My name is Yoko Katahira Abels, and I'm a junior here at Vintage. So my question was, were you nervous or worried about installing the international docking adapter, and did you fear that it would be unsuccessful?
We actually weren't that worried about any problems that we would have on the spacewalk because we know that the ground teams have thought about all of the different kinds of things that could go wrong. So they actually have brainstorming sessions where they sit down and try to think of every possible contingency and how to solve them. And we did encounter some difficulties out there with the connectors, but due to the really, really excellent planning on the ground team's part, we just worked through all of the problems. But I do think that I breathed a pretty big sigh of relief when the docking adapter was finally installed on the front of the space station.
Thank you.
Hi, Kate. My name is Gunnar DeYoung. I'm a sophomore here at Vintage High School, and my question to you is this. What's the most burdensome task you had to complete to accomplish your duties on board the International Space Station?
So I get asked that a lot. What's the hard part about this job? And my answer is both everything is hard and nothing is hard. We're having so much fun up here that just every single activity in the day is so fascinating. I'll give you a couple examples. Today, we sequenced the 1 billionth base pair of DNA. We started out in Expedition 48 at 0 base pairs of DNA. We established the sequencer on board, and we've gotten to 1 billion base pairs of DNA already. So I'm a genomics background. I get really excited about that kind of stuff. My crewmate, Takuya, and the ground teams launched 2 satellites from the space station today. We actually got to see those pass under us. So when you have those kinds of activities, I don't think that there's really anything that gets boring or burdensome up here.
That's awesome. Thanks, Kate.
Hi, Kate. My name is Ryan, and I'm subbing in for somebody. I'm a sophomore, and my question is, what is your least favorite thing about being in space?
That's kind of an easy one. There's nothing. Everything is pretty fantastic up here. Being in space is amazing. Just even little daily things like floating around or trying to eat breakfast when everything floats away. It's all kind of a source of wonder and constant fascination because it feels like the laws of physics have totally changed up here when you're floating.
Thank you.
Hello, Kate. My name's Cutler Lowe, and I'm a freshman here at Vintage. And my question to you is, how has the development of space research advanced since the start of the ISS?
ISS has had a long history, and it's been flying for 16 years, but even before that, folks were doing development work for space biology, and of course we had a long space biology program on Shuttle and Mir. So we actually have quite a history in this field. What Space Station has done to advance it is it's an orbiting laboratory, so you can see all around me in the lab we have equipment, we have scientific experiments going on. The astronauts take part in a lot of experiments actually as human research subjects, and then we do a lot of experiments as well. And so the kinds of advances that we've made are particularly in things like material science, trying to understand how we're going to go beyond low Earth orbit, what we need to do in order to explore beyond our planet, as well as biological science and human research, cellular and molecular biology. I might be a little biased because that's my field, but I think that's just absolutely taking off right now, and we're starting to see exponential increases in the kinds of research and the amount of research that we're getting out of the space station.
Thank you, Kate.
Hi, Kate. My name is Cole Geschwender, and my question is, while working with heart cells in space, what is your biggest challenge?
That's a great question. The heart cells was a fascinating experiment. I hope you guys got to take a look a little bit at some of the images and the videos coming down from that. We saw cardiomyocytes, the heart cells, actually beating in space for the first time. And one of the hardest challenges with that is keeping everything sterile. So we have a special facility that's a glove box where we can keep everything clean, but it's a little bit of a high risk. If you get one tiny microbe in there, it could ruin your whole experiment. So I felt a lot of pressure to make sure that I kept everything perfectly sterile and perfectly clean for the researchers.
All right, thank you.
Hello, Kate. My name's Angel Diaz. I'm a freshman here at Vintage High School, and my question for you today is, do you think that if the heart cells react in a positive way that we could potentially be closer to living in space?
I think so. There's a lot of things that we're learning from the fundamental research that we do up here. And the heart cells culture was a demonstration of how we can do cell culture on orbit. It's also potentially going to lead to some understanding of how these heart cells behave in microgravity. So the researchers are studying a number of different parameters. And I think we're going to learn a lot about the effects on cell culture. And potentially we can draw some conclusions about cardiovascular systems. We also have a huge research component that's studying humans. We're the lab rats up here, and we have quite a number of studies that are looking at our cardiovascular systems as a whole on board. And so we're just getting a ton of results out of all of these different kinds of studies.
Thank you.
Hi, Kate. My name is Madison Fernandez, and I am a freshman here at Vintage. My question to you is, can your tests help prevent cardiovascular disease on Earth?
Yeah, ideally we would like to learn more about cardiovascular function, and that's one of the fascinating things about spaceflight is that normally all of the fluid that would get drawn down into your legs floats upward, and it's called fluid shifts, and that actually has an effect on cardiovascular function. So we can use spaceflight as a variable to help us start to understand a little bit more about heart function. The other thing that was really fascinating about the cell experiments is those actually use reprogrammed stem cells. So those are adult stem cells that are programmed to make them behave like heart cells. And that technology in general is how we're learning a lot about all kinds of different cell types, including heart cells and potentially cardiovascular disease.
Thank you.
Hi, Kate. My name is Samantha Garcia, and my question for you is, have you discovered anything unexpected during your experimental process? If so, what, and will it affect your result?
Yeah, and that's one of the best things about being a scientist is that you can do some experiments, some things unexpectedly happen, and a lot of times in science, that's how we learn a lot. That's how we make breakthroughs in the field. And so one of the things that's been really interesting and unexpected for me is just how fluids behave in microgravity. And so you can see this all the time. We drink our water out of a drink bag, and you can make bubbles of water. And the way that these fluids behave in microgravity, to me, is very unexpected. So one of the key things that I'd like to take a look at is actually how very small amounts of fluids behave and how they're influenced by the types of material that those fluids are sticking to.
Okay, thank you.
Hi, Kate. My name is Lindsay Newberry, and I'm a senior here at Vintage. And I was just wondering, what other work besides molecular biology do you work on? Like, do you work on engineering and regulating the station?
We do. We do all of the station maintenance up here. So we actually get a lot of training on how to do maintenance. It's kind of the same thing as it would be working on your car or building a radio in your garage at home. And we have great folks at Johnson Space Center that train us how to do all that maintenance. So for example, just this morning on the left-hand side, we're working on installing a payload, and we're doing a bunch of maintenance to install that payload. And right before I talked to you guys, we were working on the oxygen recharge system. So on the space station, we recycle all of our air and our water, but every now and then we need a little bit of recharge of oxygen. And so one of the things that we do as maintenance is to install new tanks of oxygen up here. So you have to be a little bit of everything. You're a scientist in the morning maybe, and a plumber or an electrician in the evening.
That's so cool. Thank you.
Hi, Kate. My name is Connor Castellazzo, and I'm a 10th grader here at Vintage. And my question is, since you're weightless, it seems like it would be hard to control your movements and where you're going. So do you ever get any bumps or bruises while you're floating around?
Yeah, you have to be careful not to fly head first into a hatchway. And we notice that new astronauts do that a lot. When they launch themselves through the module, they're used to accounting for the natural pull of gravity. And so they launch a little bit high, like you'd throw a ball in an arc. That's not a good idea up here on Space Station because you're going to go straight in whatever vector you launch in. But you do learn within just a couple weeks how you can move yourself around from place to place. So you can go, you can bounce off the walls, you can flip upside down. You learn almost naturally and intuitively how to do that.
All right, thank you.
Hi, Kate. My name's Emily Gallard, and I'm a senior here at Vintage. I was curious, do you notice if your body is unable to take on as much physical demands as it could while on Earth? Is sleep deprivation a result?
Yeah, that's a great question, and there's a lot of people at NASA that study things like human performance and how we can get the maximum amount of performance out of astronauts and human beings in general. One of the things that we do up here is a lot of exercise. It's really important in maintaining our bone and our muscle health. So we work out 2.5 hours a day. I really like working out on Earth, so it's actually pretty fun for me to be able to do that, and it's really critically important for our bone and muscle mass. I do notice that we actually have better recovery up here. So something on the ground that would be really hard, like a track workout, sprinting, or a CrossFit workout that would leave me really tired on the ground, I wake up the next morning and I'm ready to go again. So I think there's something about floating and being in weightlessness that actually leads to better recovery and to better sleep for me.
That's awesome. Thank you.
Hi, Kate. My name is Martha Arroyo, and I was just wondering if there's a difference in how your body reacts to exercise in zero gravity than here on Earth, and what is sweating like?
Yeah, so when we're doing all of this exercise up here, we do notice something on Earth which is different than on Earth, which is the fact that on Earth, a lot of times you get some stabilization from gravity. Up here, you're on a pivot point, and so you learn really quickly exactly where to put that bar on your shoulders. You almost have to have perfect form when you're doing exercises up here. I like it because it forces you to be a little bit better at all of your exercises, but it's very different from gravity, where you can kind of cheat a little bit by having a stable platform. And in terms of sweating, it's kind of interesting. It just sort of collects, and it'll end up pooling on your face or pooling on your body. So we always have a towel handy to dab off, because the sweat will just kind of go along your skin when you're working out really hard up here.
Thank you.
Hi, Kate. My name is Alexis Betancourt, and I was wondering if you ever get homesick. And if you do, what do you do about it?
We're always thinking about our family and our friends up here. And one thing I've noticed about being far away from home in a remote area, I used to do a lot of work in Africa, is that you do think about home a lot more. You take it for granted when you're around and you're at home and you're with your loved ones. But when you're far away, particularly in a really remote area, you do find yourself thinking about it. And I will notice when we go over California, I'll wave a little bit at everybody down there. Or when we go over Houston, that's where my husband lives. I always like to look out the window and see us flying over those cities.
Thank you.
Hi, Kate. I'm Andrea Coe, and I was wondering if there's any vintage courses that help you become an astronaut or inspired you to become one.
Yeah, and I would say actually all of them. I mean, it's amazing to me the things that I learned in school that are really coming home to roost here. One of my examples is geography. I maybe didn't pay so much attention to continents or cities or capitals. You really pay attention to that when you can actually see it from above. So you see the shapes of all continents. You can see the entire United States in one glance. I constantly find myself looking out the window and thinking, oh, is that Morocco? Oh man, okay, that's the southern part of India there. You can see all these recognizable shapes. Even things like languages is incredibly important up here. We converse in both Russian and in English with our crewmates, and so the ability to learn a second language is critical. Of course, science and the math are some of the fundamental things that we're doing up here. But all of these other things really come into play. So my message to you guys is pay attention in school, because you never know what you're going to need and when you're going to need it.
Thank you.
Hi, Kate. I'm Jessica DeHaro, and I was wondering, what is the most difficult variable to control in space?
So there's actually a lot of things that are challenging to control for in space. What we want to do with our experiments is isolate microgravity as a variable. And so there's all kinds of ways that you can set up to make sure that your system is just looking at microgravity. One of the ways that we do that is to take every single experiment and run an identical control on the ground. So oftentimes researchers, at the same time that we're doing an experiment on board, are doing that exact same experiment on the ground. And in that way, you can make sure that everything in your system is identical, with the exception of, for on-board, microgravity.
Thank you.
Hi, Kate. We have time for just one more question.
Hi, Kate. My name is Madison Castellazzo, and since Mr. Pierce is now our principal, we were just wondering what he was like as a teacher, and if you can remember anything funny from his health class.
I love that question. Mr. Pearson was a great teacher. He was a really, really excellent teacher for me. I still remember his class. What I can tell you is that he was also our soccer coach, and he made us run laps. So when you guys are doing your PE or running your laps, you can thank Mr. Pearson for keeping you in excellent health.
All right, thank you.
Kate, this is Mike Pearson again. Thank you so much for being here. I want to see a VC flag on that spaceship here pretty soon, so please make sure that happens. And I noticed a little bit of a Houston twang there. That's new. I like that. So on behalf of Vintage High School, thank you so much for hosting us today. This truly is a once-in-a-lifetime experience for all of us, and you showed all of us that we too can achieve our dreams. You might not know this, but we affectionately refer to Vintage as the best school in the universe. Today, thanks to you, we are not only the best school in the universe, but the luckiest school in the universe. And when you leave the space station, please make sure to come back to Vintage High School so we can host you for a longer visit. Sounds good?
Absolutely, and it was really a joy, a complete pleasure to talk to all of the students at Vintage High School today. And I just want to say, go Crushers.
Yeah, let's give it up.
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you, Houston.
Thank you to all participants and guests from Vintage High School. You had some really great questions. We are now resuming operational audio communications.